Today we're going to look at some parallelograms, and so we're going to start by looking at an exploration. So go to Classroom, and in Classroom go ahead and open up this link for a parallelogram exploration in Geogebra. You can click on that, click on Open in Safari, and what you'll get is you'll get a parallelogram here that you can move around. You can change the shape of it, change the size. You'll notice the sides are measured there. Don't worry about any of these dots on the left side. Leave those alone, but you can change the checkbox there. You can show some angle measurements. You can show the diagonals, maybe take the angle measurements off because that's a little too much. Okay. And the question is, what things seem to always be true no matter how you move the parallelogram? What things are always true? What thing about the parallelogram? So talk about that with your group, explore, move the parallelogram around. When you think you have something, share that with your neighbor and see if they agree with you. All right, go for it. Try that out for about 3 or 4 minutes. We'll pause the video and explore there. Go for it. All right, did you make some discoveries? Hopefully we did. Okay, so now with those discoveries that hopefully you discussed together, let's think about these. Stay where you're at, okay? And let's find these out. So move your parallelogram around. And what seems to be true about opposite angles? Can you see what's true about the opposite angles in those? Okay, so if we turn on the angles, look at the angle measurements. I got 103.4 to 103.4, 76 and 76. Interesting. And I got, let's see, this guy, 36.3, 36.3. Those are the same. Okay, it looks like opposite angles are always congruent. Do you see that? And that is true. Opposite angles are always going to be congruent. Don't worry about writing this down right now. We'll get this in a second. Opposite sides. What about those sides? What's going on with those things? Can you tell? Well, it looks like they're congruent also. So 6.4, 6.4, 8, and 8. Our opposite angles are always congruent. Hopefully you found that one out too. And now, in a parallelogram, what do you notice about the angles that are next to each other? What about these guys right here? 89.7 and 90.3. Well, they're not the same, but they do add to something interesting. How about that one? How about 141 and 39? What's interesting about those? Well, notice they add to 180. So those guys are supplementary. Okay, so there's some discoveries hopefully you made. And while we're here, one more. If we click on the diagonals, what do we notice about the diagonals? Well, they're different lengths, first of all. Here we have a short diagonal there and a long diagonal there. So they're different lengths, but notice E is the midpoint. And so it cuts both the segments in half, all right? So both the diagonals cut each other in half. We say that they bisect each other. That's the key there. All right? So diagonals bisect each other. That's the key. All right. You can hit done right at the top there and go open up your notes. Let's jot some of this down and see how it works. Okay? So hit done. Go back to your notes. Open those notes up. And let's jot some of this down together. See what we can make of it. When you get to your notes, go ahead and go to the bottom of the first page there, and we'll jot these down. Opposite angles are congruent, opposite sides are congruent, and the angles that are next to each other are supplementary. Okay? So let's investigate this a little bit. We're going to kind of cruise on through. If things go a little quick here for you, then you can look at this video later. I'll post it in Classroom so you can look at it. All right? So back up to the front real quickly here. Here we have a parallelogram. The definition of a parallelogram is that opposite sides are parallel. Okay, that is the definition. Opposite sides are parallel. Okay? And we have some ways to note that. Opposite sides are parallel. We put these arrows like this, and that's going to mean that those two sides are parallel. And we can put double arrows like this. That means that those two sides are parallel. So the definition, opposite sides are parallel, that's what makes it a parallelogram. Okay? So we're going to have 5 important things today, and that is the first one. Okay, let me number that. Number 1, big important thing. Okay? You're going to have these 5 things memorized. Okay? Opposite sides are parallel. That's what makes it a parallelogram. Opposite angles are congruent. Actually, you know what? Let me make that number 3. We're going to say opposite sides are congruent. Opposite angles are congruent. And angles that are next to each other are supplementary. Those are called consecutive angles. Okay? So these are some important things that we need to know about a parallelogram. And if you flip the page there, onto the second page, you can see those theorems. Those theorems are things that we can prove to be true. And so we can see here, opposite sides are congruent, and then opposite angles are congruent. All right, those are our 2 important things, 2 of our 5 important things that we need to know. All right? So down at the bottom there, a couple quick examples. So how big is y? Well, look at these angles. They're opposite. So since they're opposite, y and 65 have to be equal. Opposite angles are congruent. And what about the opposite sides? Well, x plus 4 is one side, 12 is the other side, so x plus 4 and 12 have to be the same thing. Opposite sides are congruent. Subtract 4 from both sides, we get 8. Okay? How about these bottom 2? Let me pause just a second, let you think about this here. Okay? So look at that, number 1. Try to solve that for yourself. We want to find FG. That means the length of FG and the measure of angle G. Can you see it? FG is this opposite side, opposite 8. So this guy's got to be 8 also, right? Measure of angle G is opposite of this angle. So this guy's got to be 60 degrees also. Remember that M means measure of angle G. Okay, how about these guys? Now we're going to get into some equations, nothing too difficult. Okay, we got these opposite angles. What do you know about them? Well, hopefully we remember that opposite angles are congruent, so they're equal. And we can divide by 2, and x is 25. How about those sides? What do we know about opposite sides? Well, in a parallelogram, which, by the way, notice these are parallelogram because of the angles here, so we know that's a parallelogram. So opposite sides are congruent. So y plus 3 equals 18. So y equals 15. Okay? There you have it. Okay? Down at the bottom of that page, let's see, that is the bottom 1, 2, no, that's the top of the next page. Okay, so we did this exploration, all right? So we saw that if we have a parallelogram, the diagonals will bisect each other. So these will cut each other in half. So we can jot that down. The diagonals bisect each other. In a parallelogram, the diagonals must bisect each other. Okay? So they cut each other in half. They're not the same necessarily, but they bisect each other. They cut each other in half. Okay? So that is our number 5, by the way. That's our 5th thing that's true about all diagonals. Okay? So at the bottom of that page there's our theorems. Okay? Consecutive angle theorem. These angles add up to 180. They're consecutive. So the word we're using is consecutive. Like when you go around one after the other, those are consecutive angles. One comes after the other. Okay, and they add up to 180. All right? And then we just said the diagonals bisect each other. That's the key. Okay? So we should have, this should be at the top of the next page. Unless I lost a page. I don't think so. Top of the next page. See the parallelogram there? A little Pixar lamp there and a desk lamp. Maybe you've had a lamp like this before. Okay, so we've got a parallelogram. Parallelograms can be used a lot for mechanical devices like this, when we want things to be parallel. And if we know that this angle ADC, all right, so we've got ADC, this guy right here, and we're told that that's 110 degrees. We want to know how big this angle is right here. What's going on there? Angle C. Well, these guys are consecutive angles. Notice they're one after the other. Okay, so since they're one after the other, this one's 110. Okay, I know, well, it's x plus 110. They're not equal to each other, but they add up to 180. Okay, so this angle x, or this measure of angle BCD, is going to be 70. Okay, all right. So they're supplementary. Very good. All right, let's try another one out here. I'm going to let you try this one out. Okay, so we want to graph this, and we want to find the coordinates of the diagonals, the intersection of the diagonals. Okay, and I'm going to remind you of something. I'm going to remind you of the midpoint formula. Do you remember the midpoint formula? Okay, midpoint formula says if you have 2 points, x1, y1, x2, y2, and you want to find the midpoint, then average the x's and average the y's. All right? Okay. So what I need you to do is I need you to plot these points here. Go ahead and plot these, draw the parallelogram, and then find the coordinates of the intersection of the diagonals. Okay? Go ahead and we can pause the video and take about 4 minutes there. Should be fine. Take about 3 or 4 minutes. Graph the parallelogram and then find the coordinates of the vertex. Go for it. So we should have got something like this. L is there. O is at 0, 0. 7, 4, 1, 2, 3, 4, 5, 6, 7, 4 is M, and N is there. So there's our parallelogram. We want to find the intersection of the diagonals. Okay? And so if we draw in the diagonal something like that, we get an idea, but if you freehanded it like I did, which you did on the iPads, I assume there, so we don't know exactly. We've got a good idea, but probably not too exact. But we know that this is the midpoint. So if I want to find that point, I can take 2 opposite points, LN, and let's find the midpoint of those. Let's use these coordinates. We're going to average the x's, and we're going to average the y's. Remember, average means add and divide by 2. So we get 7 halves and 4 halves, which is 3.5 and 2. So the coordinates of the intersection point here are 3.5, 2, because they bisect at their midpoint. And we can check the other way too, and we'll see if that's true. Let's do that real quickly. Let's go ahead and look at these two. Okay, hopefully you have one of these. All right, and let's see if I can break this up. There we go. Okay, so we're going to take these two. Let's take 7 plus 0 divided by 2, and take the 4 plus 0 divided by 2. And that's going to give us 3.5 and 2 again. Okay, same midpoints. Okay, so the midpoint's at 3.5, 2. All right, great job. So almost there. And let's look at one more problem. Try plotting these vertices, -1, -3. There's W, and -3, 2. There's X. Z is at 4, -4. Okay? And we have a parallelogram, WXYZ. So that means we go from W to X to Y somewhere to Z. Okay? The question is, where is that point 1 somewhere out here that will make this a parallelogram? See if you can find that, all right? We know we want it to be parallel. We need a parallelogram. Opposite sides are parallel. Can you find the vertex? Think about slope. The slope here, we're going down 1, right 2. So if this slope's going down 1, sorry, right 2, right 5, how about that? So the slope of the opposite side's got to be the same, right? Down 1, right 5. What does that do for us? How about that? Is that parallel? Well, let's see. This XW is going down 5, right 2. And so if we check here, we're going down right 5, 2. Down 5, right 2. That will give us that point. So it looks like we found it. So by using slope, we can see there's Y. The point is 2, 1. So here we see the slope of the opposite sides have to be the same, and that's how we can locate a point like this. All right, well, we're going to stop there. There's one more page at the end there of those notes, but that's good for now. So stop there, and we'll go to our assignment, and let's put some of that into practice. Remember your 5 things. Let's recap those real quickly. Our 5 main things. We've got the definition. Opposite sides are parallel. We have the things we discovered here. Opposite sides are congruent. Opposite sides or angles are congruent. And these are consecutive angles. Consecutive angles are supplementary. And then the last thing that we found was that the diagonals bisect each other. Those are 5 things that we got to get down. All right? All right. Go for it.